Okay, well, let's look at some multiplication of polynomials. We'll first start off with just a binomial times a binomial. Let's go ahead and make that a plus. And what you've got to do is you've got to make sure that you take every term, each one of these is a term, each one of these is a term, and make sure it's multiplied by every term in the other one. Now, with a binomial, 2 term times 2 term, we've got a little trick that we use to remember how to do it. FOIL, first, outer, inner, last. But the thing is, I don't like getting tied to FOIL because, well, what happens when this becomes one with 3 terms and not just 2? Well, FOIL doesn't really work anymore, but the distributive thing does. So what I do is I take an x times x and x times 2 and negative 3 times x, negative 3x, and negative 3 times positive 2. And then we can combine these middle terms because they're like terms. And we're going to end up with x squared minus x minus 6. So there is our solution to x minus 3 times x plus 2. Now, as I was saying though, what happens if we end up with one that's like x minus 3 times x squared plus 2x minus 5? Well, now we don't have a binomial times a binomial, we have a binomial times a trinomial, and FOIL just goes out the window. So FOIL is a good memory tool for binomial times binomial, but that's it. Whereas if you take and you distribute, and you get that into your mind, you're always going to make sure you get everything multiplied out. So I would multiply the x times the x squared and get x cubed, and the x times the 2x and get plus 2x squared, and the x times the negative 5 and get negative 5x. Then, once that x has been multiplied by everything over here, I move to the negative 3. Treat this as a negative 3 and distribute the negative 3 all the way through. Negative 3 times x squared gives you negative 3x squared. Negative 3 times 2x is going to give you negative 6x. And negative 3 times negative 5 gives you plus 15. So then you just go through and you clean it up by combining like terms. No x cubed terms except for that one. We got plus 2x squared and minus 3x squared, so that's going to give us negative x squared. Negative 5x and negative 6x gives me negative 11x. And then the 15 has no like terms to combine with. So there's your solution. Now, remember when you're multiplying, just in case you need this brush up, sorry about that, when we multiply like x times x squared, remember this is x to the first power, and when we multiply x's, we're going to add the exponents. That's where this x to the third comes from. That's where when we get x times 2x, we get 2x squared. This 2x squared here. Though we understand that there's a 1 here, times the 2, that's where the 2 comes from, and x to the first times x to the first gives us x squared. So that's where those come from. Alright, so let's look now at a division problem, division of polynomials. And I've just made this up. I have no idea how ugly this is going to be when we get into this, but we'll find out. But first I want to go back just a little bit and think about, let's say probably about 3rd grade. And let's say we had 23, we were dividing that into 576. These are very, very similar problems. You would go in and you would say, okay, well, how many times will 23 go into 57? Which is just another way of saying, what would I multiply times 23 to get something really close to 57? And that would be 2. 2 times 23 gives you 46. I don't know why I wrote a 2. And then you subtract. So when you do that, you're going to get 11. You bring down the next one, and you go through the exact same process again. 23 will go into 116 5 times. 5 times 23, 5 times 3 gives you 15. So that'd be 115. Wow, I did a pretty good job there on my selection. And then you subtract and you're going to get 1. So the first thing we did when we were learning how to do long division back in 3rd grade is we learned R1. So it goes in 25 times with a remainder of 1. The second part a lot of people forget, and that was to take this, make it the numerator, this the denominator, and the answer was 25 and 1 23rd. And then of course the last one we remember that we continue to use to this day is we put a point here and a 0 and maybe another 0 and maybe another 0, and we end up getting a decimal. And that's nothing more than the decimal value for 1 over 23. So we're going to go and talk about both the first one and the second one. We don't have a version of the third one with polynomials. So over here, if we say, the way you want to ask this is, what do I multiply times x to get x to the third? And that would be x squared. So x squared times x gives me x to the third. X squared times 2 gives me plus 2x. And then I'm going to put parentheses here and subtract. The reason you want to put parentheses is if you just put a minus, you're just going to subtract that x cubed. You're going to end up adding over here. That's going to make a mistake, and you're going to go off bad wrong real quick. So x cubed minus x cubed cancels out, which is what we want. If that does not cancel out, you've chosen the wrong number here. This first one has to cancel out. And then negative 3x squared minus 2x, that's squared, would be negative 5x squared. And then bring down the next one, so plus x. So we're doing the same thing we did over here, we're just doing it with x's. So now, what do I multiply times x to get negative 5x squared? Well, negative 5x. Negative 5x times x gives me negative 5x squared. Once again, we can see that's going to cancel out when we subtract. Negative 5x times 2 gives me negative 10x. Parentheses and subtract. Negative 5x squared minus a negative 5x squared, subtracting a negative, same thing as adding a positive, so those do cancel out like we want. And then x minus a negative 10x, it's the same thing as adding 10x, so we end up with 11x, and bring down the next. And go through it one more time. What do I multiply times x to get 11x? Well, of course, that's going to be plus 11. 11 times x gives me 11x. 11 times 2 gives me plus 22, parentheses, and subtract. So 11x minus 11x cancels out like we want it to. Negative 9 minus 22 is going to give me negative 31, and that's my remainder. So if they're asking for a remainder, you would have x squared minus 5x plus 11 are negative 31. Now that's going to come into play later in that you're going to want that remainder to be 0, and you'll see it when you'll understand why when you see the remainder theorem for this. The other way that you can write it is the fraction way here. And what you would do, the answer to this would be x squared minus 5x plus 11 plus negative 31 on top over x plus 2. So we make that fraction out of the remainder and the divisor. So the remainder over the divisor makes the fraction that we add on to make this the true complete answer. So those are the two different ways that you can express your answer. It all depends on what they're looking for as to which one you need. But there's a little bit of review on multiplying polynomials and long division of polynomials.